to somehow connect through the cloud platform that it's hosted on. In this state of no connectivity, we don't find it acceptable in almost any other setting. We have two dominant mobile platforms in iOS and Android. Imagine a world, and some of you who are on Android who get invited to Apple iMessage threads and get the dreaded the green chat bubble, you might feel this a little bit. But imagine a world where on WhatsApp, let's say, iOS and Android users can't find each other. Or in Uber where iOS drivers can't pick up Android riders. Seems totally infeasible. So everyone here, look, we know that this world of interacting with infrastructure first is just not the end state we're looking for. We're here to celebrate infrastructure. That's what the purpose of today is. We're here to see what's the cutting edge in the world of infrastructure. But again, it's not the destination, so what is? For us, that destination is a world where blockchains are seamlessly connected, a world where all applications are what we'd consider interchain applications, a world where users interact with apps first and infrastructure only when they want to, where the knowledge burden is much more reduced. We like calling this the interchain singularity. Think about this as the point in time after which there's no going back. We're not going back to these singular, monolithic, non-communicative chains. So what does the path look like? Well, like we said, we're going to need to connect these applications. We're going to need to create these interchain applications. But to do that, we're going to have to connect the underlying chains. There's been a lot of efforts, and we're going to talk about those and kind of examine how we got to where we are today. But so here, we're trying to tell you about the interchain highway. Again, this notion of the most accessible, fast, and secure path to take between blockchains. And if any Star Wars fans are here today, you might recognize this term. A hyperlane is the fastest and safest way to travel between star systems in that galaxy far, far away. So as I mentioned, before we get into where we're going, it's worth examining the past to get a sense of all the efforts that have been made to get us to where we are today. You'll notice I have date ranges here with end dates. It's a bit misleading because none of these are over. All of these are playing out simultaneously. So I don't want you to take away some idea that any of these modes are somehow outdated or invalid. It just is, and this was kind of to give you a frame of reference. So with each one of these, we're going to talk about kind of the basics of it, and we're going to talk about the dominant form of how this mode of interoperability has been expressed. So around 2015, 2016, at a time where smart contract platforms are still really not prevalent, no one's dominant just yet, in the notion that one paradigm could kind of become the dominant one, there would be a winner-take-all type of market for smart contract platforms, this idea of the defined rule set interoperability came about. Easiest to recognize in Cosmos or Polkadot. And the idea here is we're going to create a defined set of rules for how to build your blockchain. And if you build your blockchain within these rules, you're going to get a really strong set of guarantees regarding security, speed, and to some extent finality, but only within that set of defined rules. So only blockchains that comply with these rules. Again, app chains are the most dominant form of expression here. Of course, it doesn't only have to take the form of app chains, but that's what we've seen with parachains and Cosmos app chains. Well, how's it going? It's going pretty well. In the past year, there's been an explosion of Cosmos app chains. There's a major rise in the number of Polkadot parachains. And so it's hard to argue that this is not working out well in some capacity. From there, we move on to asset-centric interoperability. This started taking form around late 2019, early 2020. And this was interoperability that's focused on the user's ability to move assets. Well, we could do that in the previous mode too. So you can see how this kind of expands on what existed, but now it's not just within that limited set. You might lose some of those nice guarantees that you got within the defined set of rules, but as part of that trade-off, what you get is now you can access chains in a backwards compatible manner. The chain doesn't have to necessarily comply for you to have your interoperability. How is this expressed most dominantly? It's been user-facing bridges. or swap protocol. So you think of things like Wormhole for a wrapped asset bridge, or think of something like Synapse for a cross-chain swap protocol. How's that going? It's going pretty well as well. There's been tens of billions transacted via these user-facing bridges. Unfortunately, there's also been several billions that have been lost in security incidents. So what you can take away from these first two, they put the burden of interoperability on the user. And that kind of made sense in a world where we interface with the infrastructure first. In these modes, it's the user gets to say, I want to move these assets, so I go to one of these interfaces, and now I move the asset around, and I go to the application, wherever the application is. I need to go and find it. As we move towards this latest era, the one that's just beginning, the one that Hyperlane's hoping to herald, we're trying to shift the burden of interoperability from the user to the application. Now, they might not change the function. It might still end up being all about moving assets around. But what it is going to change is the form. How does this take place? Instead of us as users moving assets around to find the application that we want to find, it's enabling applications to do the interoperability part, the asset move on our behalf, and allowing them to come and find us wherever we are. In this mode, now we're getting a little bit more opinionated. We certainly think that interchain applications will be the dominant form of expression here. As you mentioned, these are these apps that are somehow routed through chains, through platforms like Hyperlane. We're going to talk about that in just a second here. So, Hyperlane, the interchain highway. Again, the road to the interchain singularity, where blockchains and applications are connected seamlessly and securely. And again, after this point, we're probably not going to go back to these siloed, monolithic chains. So what is it? We're not trying to introduce another blockchain to solve your blockchain problems. This has been a pretty common approach in the last 5-6 years, where as we run into problems with blockchains, we try to solve them with yet another blockchains. Not here. Not that there's anything wrong with that. Again, we just take a different approach. With Hyperlane, we've created a network between all of these blockchains. Think of a network of networks, a network between these chains, and the interchain highway is the path between them. So how does it work? As I mentioned, no native blockchain involved. We have our contracts. The system is implemented solely in contracts. And on every chain that we support, we deploy these mailboxes. At the moment, they exist as two separate contracts, an outbox and an inbox. That's not going to be a permanent state. That's going to change through time. And they act as the main point of linkage. Think of them as the API that you as a developer would use to talk between chains. So a user's contract interfaces with the outbox. What happens then? You need to send a message to it. So that message would include the destination or destinations to which you're sending. It include a message body. In that message body, you put any raw bytes that you want. Those bytes might lead to a function being executed on a remote chain. It might swap or mint an asset. It might be something like, hey, John, how are you doing? But I don't think anyone cares. There's probably easier ways to do that. Once the message hits the outbox, it gets added to an incremental Merkle tree. And now the validators come in. This is the first leg of security in the Hyperlane system. These validators are agents that basically provide both economic and reputational security to the system. They're observing the outbox. Once they see a new message, if it's valid, they'll sign the root of that Merkle tree. Important to note that these validators are unique to each set. So it's not some like omnibus set that looks at every chain Hyperlane supports, rather an independent set on each chain. This is very important because it gives us verifiable fraud proofs. We can get into that a little bit afterwards, but in the interest of time, I'm not going to get too much into the weeds there. So when it comes to how does it work, we're about halfway through. Now the relayers come in. The relayers are a totally permissionless role. Anyone can run one. They've been open sourced on the Hyperlane GitHub. And they too observe the outbox. They're basically listening in to messages. They want to see that things look valid. Once they see those signatures for a given message have been posted, now they can start to think about processing that, basically getting it to the destination chain and performing the action of processing. Well, process runs the Merkle proofs against those signatures that have been collected. If there's a sufficient number of these signatures to justify the quorum, now things can go ahead and the message can get to its destination. But not before this thing that we like to think of as the main thing that Hyperlane brings to the table, the main innovation in interchain communication, which is sovereign consensus. Sovereign consensus is a secondary layer of defense, but unlike the validators, which act as this general network-based layer, sovereign consensus is specific to each application. The short of it is that it lets you configure, as the app developer, your security module. You can leverage what we'd call interchain security modules. These are things that you can choose from a menu of existing options or even create your own. And they can be as simple as you as the application requiring a designated validator for whom their signature must be included. So imagine a case where 99 validators say that the sky is red, but if your validator is not saying the sky is red, that message will never get processed, will never impact your application. So the idea is to put to give the application some control, some sovereignty over the messages that it can accept, because in interchain communication systems like these, you're mostly dependent on the information coming in from the validators. And we know that at a certain point, that's not going to be sufficient, especially as this platform grows. And so we wanted to give developers an option to have another layer of defense and have some customization around it. Now, sovereign consensus was something that we designed intentionally to be both modular and flexible and give developers some amount of future proofing, right? Like everyone here has probably been crypto long enough to realize these are systems that exhibit very evolutionary traits. We devise defense mechanisms, and now increasingly sophisticated predators come to try and rip those defense mechanisms to shreds. Every so often they succeed, and now we're running up to find the next one. Well, in most interchain communication platforms, what we have seen so far is that the platform says, I have devised the best security model, pick me, and now you're basically attached to that security model until you switch platforms. And there's no notion of context. The feature that I think is most compelling about sovereign consensus is this notion of you can add context and you can configure it based on context dynamically. So imagine being able to say, hey, here's a message that really is only impacting $3. Well, that's kind of low stakes. I'd much rather for that to take the trade-off of speed over security. So only send it through, say, the economic security provided by the validators. Then you have a message that wants to drain all of the contracts. Maybe that one should go through an optimistic module where you decide how long the system should wait before that message can actually be processed, to give entities like watchtowers sufficient amount of time to veto it in the event of this actually being some type of exploit, right? In our own lives, you can imagine, you go to the bank and you try to get $10 out, they barely check your PIN number. But if you try to withdraw your whole account, doesn't matter how small it is, that bank's not letting you leave in the same day. So let's talk about Hyperlane. Like, why should you care, right? What's interesting about this? What is different? What is new? So first and foremost, the sovereign consensus that we just talked about. Again, dynamic security, the future-proofing, the ability to plug in to new innovations in security as they come along. If you're paying attention, you might have noticed in the last few weeks some new papers talking about the emergence of zero-knowledge proofs into the space of interoperability. At some point, those will become really viable. Well, so with Hyperlane, we wanted to give applications that choose to use this platform the ability to stay on top of the state of the art, right? To be able to advance themselves as these evolutionary systems continue to advance. But that's not all. We're also, so there's the interchain applications that we spoke about before. You can build those in two main patterns, router patterns and hub and spoke. What's a router pattern? A router pattern is one where you have contracts on the number of chains you want to support, and you can imagine distributing messages through them somewhat equally. Whereas a hub and spoke is exactly what it sounds like. A hub and spoke is one where you designate certain contracts on a specific chains to be the hub, and then utilizing the spokes as necessary based on the incoming information and users' needs. What could you do with this, right? So like, there's a lot of interesting things that you could start thinking about, whether it's connecting up some of the lending applications, connecting up margin trading applications, as you can designate collateral on different chains. Then we move on to interchain accounts, fairly new feature. Think of these as like remote identity proxies. We were gonna call them that initially, but not everyone thought RIPs is a good acronym. I did. York here in the audience is the main author of those. If you're familiar with IBC and its interchain accounts, these are fairly similar. And at Hyperlane, we like to extend popular IBC features to the EVM context and beyond, right? So the new environments will be added. What do these interchain accounts let you do? Well, they let you, the skinny is that they let you execute functions on remote chains without ever having to deploy unique contracts to do that. Imagine being able to have a contract, say, on ETH mainnet that effectively commands or owns a number of addresses on the chains that you'd like to support. And now you could have a DAO that could transfer funds across those. You could get access to liquidity via those addresses. Whole host of other use cases that we just probably won't have enough time to get into. Last but not least, interchain queries. These are very, very new. It's the latest edition, actually only launched this weekend. So if you go into the docs and you look at them, expect rapid improvement in the docs throughout the next few days and weeks. What do they let you do? It's the ability to perform view calls across chain, to verify some information and then act on the basis of it. All right, so something that you might want to do with it. Don't know how many of y'all own ENS. I am an ENS degenerate. I own many ENS names. These would give you the ability to create some type of linkage between an ENS name and an address on another chain. They would allow you to, again, back to this idea of utilizing collateral across chains, you could verify that someone owns some amount of collateral and then perhaps extend the loan or extend some margin on the back of it. So with all of that, we've talked about what Hyperlane is today. We've talked about the interoperability things that got us to where we are, but what's next? What's coming? So if you've been paying attention to the space, you've noticed that to date, pretty much most interoperability platforms opt for what we'd call permissioned operation. Right? Not everyone gets to add their network. The creators of the protocol or a DAO behind the protocol decides on which networks get added. We don't need to be gigabrains to figure out why this is and why this has ended up the case so far. But it doesn't mean we have to like it. Now, Hyperlane's architecture is one that I personally believe, and certainly most of the folks on our team, is uniquely suited to change this state. If you look, if you take a step back and look at what we just talked about, this architecture, the mailboxes can already be deployed by anyone on any chain. The repos exist, the contracts are verified, anyone can go ahead and do that. The relayer, the necessary part to communicate between chains and initiate the processing, that's another permissionless thing, as I mentioned before, already open sourced on the Hyperlane GitHub. What's more, you could implement the mailboxes pretty much in any language. Now, I'd urge you to do that only on Turing-complete chains, but you could, if you want to have some fun with it and create a real project for yourselves, we're not going to stop you. And for us, the holy grail of interoperability is this notion of permissionless deployment. I'll tell you that for me personally, the magic of crypto really comes out when you look at the permissionless systems. I think it's the permissionless nature of blockchains like Ethereum. It's the permissionless nature of systems like Uniswap that really are the center of gravity and center of innovation in crypto. But again, we don't have that in the space of interoperability. And so with Hyperlane, in the not-so-far future, we will be providing anyone with the ability to permissionlessly deploy the system, the ability to permissionlessly add their network to the interchain highway. Think of it as like the ability to add an on and off ramp to your destination. And again, I think that this is going to be the point from which once we have this out there, now we'll be able to really accelerate the activity in the interchain space. And from that point on, there's just probably not going to be any looking back, and this type of activity will really take off. And so with that, we're running out of time, so happy to do some questions. The rest of the event, I'll be here for the next few hours. If you want to contact me or us, John at hyperlane.xyz. Our website's hyperlane.xyz. Twitter at the Pale Nimbus. Bunch of us will be here at DevCon, so just give us a shout.